This video is on proofs, and specifically we're going to be working on two-column proofs. A two-column proof is a statement and a reason. We write out the congruency statements or any statements that we can prove, and we give the reason why. We have to give a reason why or it does not work. So for this first triangles, for the first part, we write out the givens in the first statements every single time. So the first given is that segment AB is congruent to segment DE. We write that in the first statement. And we put the reason of given. The second statement is we're going to write in there that angle B is congruent to angle E. Angle B is congruent to angle E. We write it in there exactly as it's written. And the reason is it's given. The next statement is that angle A is congruent to angle D because that was in the given. So for the reason, we write the word given. What you want to do is go back to your original givens. And if it has a congruency mark and it's in our statement, we can check it off. We have congruency mark and it's in our statements, check. This one has a congruency mark, it's in our statement with the reason, check. This third one has a congruency mark, it's in our statement with the reason, check. So we've used all of our givens, so now we go back to the rest of it. We have 1, 2, 3 congruencies with reasons. We needed 3 of them to determine if we have congruent triangles. So now that we have 3, we look to see what information we do have. This is a segment. So we're going to highlight this in for segments. I have segment AB has 1 tick mark on it. Segment DE also has 1 tick mark on it. So those segments are congruent. The next thing is an angle, so I'm going to use an arc. I have angle B, which has the 2 arcs on it, is congruent to angle E, which also has the 2 arcs on it. Then we have on the third one that angle A, so it's an angle, so I'm going to use an arc. Angle A has 1 arc on it, and angle D has 1 arc on it. Now, since we have 1 side and 2 angles, we know we're going to have 2 A's and 1 S in our answer, in our why are these triangles congruent. So whatever your proof says, it says prove that triangle ABC is congruent to triangle DEF. That is what you put in your very last statement. But you have to determine the reason. This goes back to the side, side angle, side angle, anything like that. It's those 5 things that you can use. The 5 things that you can use are side, angle, angle, side, angle, angle, side, and HL. HL can only be used with a right triangle. This is not a right triangle, so you cannot use HL. There are 2 angles, so we know we're going to have 2 angles and 1 S. It's going to be one of these 2. This side, this pink, touches both the blue and the purple. So this side right here touches both the A's. Because if you were to extend the S, it would touch the first A and it would touch the second A. So this reason would be angle, side, angle. We put angle, side, angle. That is the reason why those 2 triangles are congruent. On this next proof, we're going to do the same thing. The first thing you start with is your given. So our segment PQ is congruent to segment RS. That's the very first thing we write. Segment PQ is congruent to segment RS. We write in here given. It's already put there for you. Does it have a congruency mark? Do we have it in there? We can put a check mark on it. The next thing in our given is that angle PQS is congruent to angle RSQ. So angle PQS is congruent to angle RSQ. It has a congruency mark. It is in our statement with the given. We can put a check mark. That is all we have in the givens. But we only have 2 check marks. That means that we have to find a third thing. So we come down to the picture and we find anything else that we could mark congruent. This goes back to those other theorems and properties, definitions, postulates. These triangles are attached to each other on this side. What that means is that we can say that this side is congruent to itself because of the reflexive property of congruence. The reflexive property. Reflexive property. That means I can put 2 tick marks on here because it is congruent to each other. This is the same side on both triangles. They fit perfectly on top of each other. That means that they have to be the exact same length. So they are congruent to each other because of reflexive property. So now if we look at all of our statements, we have 1, 2, 3 congruency statements. That means that we could look to see if we have enough information. We have a side, PQ, is congruent to RS. We have the tick marks. So I can highlight that in pink. PQ and RS. Then we have angle PQS. So I can outline that in purple. It's an arc, PQS. So Q is the vertex. And angle RSQ. S is the vertex. So I'm going to go down to S. It also has 1 arc, so I'm putting that in purple. And then the next one is QS is congruent to QS. So I can highlight that in blue. Now, if you look at each individual triangle, you have 2 sides, 2 highlight, and you have 1 angle. Now, that angle is actually touching both of the sides. It's touching the pink and the blue. So the 2 sides that touch with the angle that touch both of the blues, or both of the highlights, sorry. So the A touches both of the S's. So this would be side angle side. It's not going to be side, side, side because you don't have a third highlight. So this will be side angle side. And you would see on this one, it has the exact same thing. You have the 2 highlight plus the 1 angle touches both of the highlighters. So it'll be side angle side. So we would put in the last statement the proof. Triangle PQS is congruent to triangle RSQ by side angle side. On example 3, we have our first thing is our given. So segment AB is congruent to segment DE because of it's given to us. So we can put a check mark because it has a congruency symbol. Statement 2, we put our second given, which is segment AC is congruent to segment DF. And we write because it's given. It has a congruency. It's in our proof. We can put a check mark. The next thing, we still have a given. We put this into our third statement. Segment BC is congruent to segment EF. The reason is that it's given. It has a congruency. It's in our proof. We can put a check mark. That's all of our givens, and we have 3 check marks, meaning we can look to see, do we have enough information? We have a side, and a side. So we should have all 3 sides. So we have 1 tick mark, 1 tick mark. 2 tick marks, 2 tick marks. 3 tick marks, 3 tick marks. That means that these are congruent by side, side, side. So our final statement will be whatever our proof says. It says prove triangle, so we write out triangle ABD is congruent to triangle DEF. Triangle DEF. And what we put for the reason was that side, side, side. And you could highlight those. Example 4. First thing we write in our statements is our givens. So we have angle L is congruent to angle N. Angle L is congruent to angle N because it is given. It has a congruency. It's in our proof. We can put a check. The next part is angle LOM is congruent to angle NMO. That goes into our second statement. Angle LOM is congruent to angle NMO because it's given to us. It's a congruency. It's in our proof. We can put a check mark. And it's all marked inside of our picture. That's all of our givens, but we only have 2 check marks. So we have to look at the picture to see if there's anything else that we can prove using the other theorems, postulates, definitions, or properties. So these 2 triangles are actually flush to each other along this line of MO. So we want to use this to prove congruency because these 2 lines are the exact same for both triangles. These are congruent to each other. So the way we name this is really important because you have to name them appropriately. So using this first triangle, using this top triangle, we can name this segment any way we want to. We can name it MO or OM. So I'm going to name it MO, segment MO. It's congruent to segment. Now we can't name it MO unless it is allowed to be. So on this other triangle, if we started with M, we started with the 2 arcs. So on this part, which part has the 2 arcs, the M or the O? The O has the 2 arcs on it, so we have to use the O first because it has to go in order of what we used. So we have to go from O to M this time because of the reflexive property. So now we have 1, 2, 3 congruencies. We have 1 angle, 2 angles, and 1 side. So we have 2 angles and 1 side. So the question is this, so we have 2 angles and 1 side. So is our side touching both of the angles or only one of the angles? You see how this S is only touching this angle right here? So if we come down here, if I were to just cover up one of the triangles, I just want to look at one triangle at a time. One triangle at a time. So I cover this triangle up. This side, if I were to highlight this side, is this side going to touch both of these arcs if I were to highlight it, or will it only touch one set of the arcs? So if I were to highlight this, my pink highlighter, is it touching the 1 arc, the 2 arcs, or both sets? It's only touching the 2 arc. So it's only touching one set of them. So I will come back up here and think, which one is it touching? Is it touching both of the arcs, marked angles, or touching just one of the marked angles? It's only touching one of the marked angles, so it should be angle, angle, side. So the reason these 2 triangles are congruent is because of angle, angle, side. This next one, and our first statement is still always your given. So AE bisects segment BD because it's given. This does not have a congruency symbol, so I cannot put a check mark on it. We have to come back to it after we do all of our givens. The next statement will be that angle A is congruent to angle E because it is given. And it is given. This has congruency, and it is in our proof, so we can put a check mark. We only have one check mark. We only have one check mark. That means we have to go back to the given and see what words are in that. Since it has a word, we have to underline the word and then circle the next part. It says bisect. Bisect means to cut in half. Bisect means to cut in half. And we're going to focus solely on BD. So only look at segment BD. So this time I'm going to highlight BD in yellow, because this is what I want to focus on. That BD, segment BD, is being bisected. That's being cut in half. So BD is changing. So we can actually say that BD is being cut in half. So what just got formed here? We now have two congruent segments, and we can write that in here. We can say that segment DC is congruent to segment BC. And that's because of the definition of bisect, because the word bisect in here, we have definition of bisect in our reason. Now that I have a congruency because of bisect, because I've used that word, now I can put a check mark. Now I have two check marks and I have no more givens left. But I still only have two check marks. Means I only have two congruencies. I still have to look at the picture, because we have to get that third thing. Because we only have, from what we've done so far, we only have two congruency marks. So if we look here, it says angle ACB is congruent to angle ECD. Now it's an angle, it's at, and you see that C is in the middle. That is our vertex. That's the angle we want to focus on. So we go to angle C, and it says angle ACB. So ACB, so it comes here. Two arcs on here. Then it says angle ECD, so ECD, so right here. Two arcs on here. Now, why are these two angles congruent to each other? Do you see how the two angles are actually touching at a point? And it looks like we can form the letter X with these two lines. If we can form the letter X, those are vertical angles. These are congruent because of vertical angles. Vertical angles. Now we have that 1, 2, 3 things congruent. Now we can look to see if we have enough information. We have one angle congruent, one side congruent, and another angle congruent. We have two angles and a side. Two angles and a side. So it's either angle, side, angle, or angle, angle, side. We got to figure out, is the side touching just one marked angle or both of the marked angles? Okay, it's coming back down here. Here's our yellow side. So again, we're going to just focus on one triangle at a time. So one triangle at a time. Covering up the other one. This is our marked side. It's highlighted in yellow. Is that yellow touching both sets of arcs or just one set of arcs? This one down here doesn't have any yellow near it at all, but this set of arcs has yellow on it. It's touching that single set of arcs. So it's only touching one set of arcs. Can we say the same thing about this one? This yellow is only touching one set of arcs because this arc has no yellow near it at all. So it's only touching one set of arcs. So it's only touching one of the A's. So of these two, this S is touching both of the A's. This one's only touching one. That's the one we want. So we can say that the triangles are congruent from our proof because of angle, angle, side. On this next one, we have that segment PQ is parallel to segment ST. So that's our first statement, and we put given. Now that does not say they're congruent, so I can't put a check mark yet. We go to the next given. It says that segment PR is congruent to segment TR. PR is congruent to segment TR, and it's given. Now it's marked. It's in our proof. We can put a check mark in it because it has congruency. I only have one congruence, and I've done with my givens, so I have to go back to my givens and find words. Now it says parallel. Parallel means that we're going to look for two types of angles. Parallel. I'm going to draw a little arrow over here and say we're looking for if alternate interior angles. They are formed when we have a Z, and it's the corners. We could also be looking for corresponding, which are formed with the F, and those are the corners. Now, again, the parallel parts are the ones that are the horizontal parts. Those are the parts that we're looking for. So we don't have any markings on here, so we have to show that PQ is parallel to ST. So PQ needs to have an arrow on it, not a congruency, an arrow. And an ST also needs to have an arrow on it. So now if I were to look at those two lines, these two lines, will I be able to form an F or a Z? And I can actually form a Z going this way. Since I want to look at angle P and T, because that's what my statements say, it's telling me to specifically look at angle P and T, I can form the Z between P and T. What that means is that we have angles, alternate interior angles. Angles are congruent. So we can have angle P is congruent to angle T because of it's the Z, so it's alternate interior angles. We would say alternate interior angles. Now we have a congruency because of the parallel, so I can put a check mark now on that. Still only have two check marks, so I only have two congruencies. So now it says, looking at our statements, because we always read our statements, see if we have them. It says angle PRQ is congruent to angle TRS. So angle PRQ, it's this angle right here. It's congruent to angle TRS. R right here, two arcs. Now why are these two angles congruent? These two are formed at that X. When you form an X, you have vertical angles. So these are congruent because of vertical angles. Vertical angles. So now we have the three congruency statements now. So we have 1, 2, 3. This is a segment, so it's an S, an A, and an A. So 2 A's, 1 S. So again, 2 A's, 1 S. We got to figure out if the side is the congruent side is touching both sets of angles or just one set of angles. So our congruent side is right here. Those are our congruent sides. That has the tick mark on it. So again, just focusing on one triangle at a time. Is this pink touching both sets of arcs or just one set? It's touching both the green and the blue arcs, so it's actually touching both sets. Can we say the same thing over here? This is touching, the pink is touching both sets of arcs, so it's touching both sets. So coming back up here, this S is touching both sets of the A's, so it's ASA. So we would say, from our proof, that triangle PQR is congruent to triangle TSR by angle, side, angle.